Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to discuss about the concept of PGP cryptographic keys and rings. PGP cryptographic keys and rings. So in this PGP, the pretty good privacy is a encryption service which is used to write security mails. So in the network security, the cryptographic keys are very important role to provide the encryption or decryption services. So here the cryptographic keys and the key rings are very important generating keys, very important generation of the keys. That is nothing but a random session keys, symmetric keys, public keys, private keys. So here there are different types of cryptographic keys and the key rings are there. Cryptographic keys and the key rings are there. So here the PGP makes use of 4 types of keys actually. So generally PGP is nothing but what? Pretty good privacy, and it is a encryption service or encryption mechanism or encryption technique. We can call it as in any way. That PGP service makes with the help of these 4 types of keys. 4 types of keys. So in that, the first one is what? One-time session symmetric keys. One-time session symmetric keys. And the second one is what? Public keys. Second one is what? Public keys. And third one is what? Private keys. Third one is what? Private keys. And the fourth one is passphrase based symmetric keys. Passphrase based symmetric keys. So all these keys are very important for generating keys. So in the real time, we have seen different types of OTPs generation, captcha generation, and password generations. So all these types of generations, all these types of OTP generations, captcha generations, or password reset generations, like the way all these types of applications are enabled because of these 4 types of keys are presented. So what are these 4 types actually? One is one-time session keys, that is symmetric keys, and second one is public keys, and third one is private keys, and fourth one is passphrase based symmetric keys. So 3 separate requirements can be identified with respect to these keys. So 3 separate requirements. What are those requirements actually? So with these keys, the separate requirements are identified. So the first one is what? It means of generating unpredictable session keys is needed. One is what? It means of generating unpredictable session keys needed. Unpredictable session keys needed. So which are used for the sessions or which are not used for the sessions. So generating unpredictable session keys is needed. The first one. And second one is we would like to allow a user to have multiple public key or private key pairs. Would like to allow a user to have multiple public key or private key pairs. That is nothing but user is enabled with the multiple public keys and private key pairs. That user have multiple public key and private key pairs. As a result, there is not a one-to-one correspondence between users and their public keys. So by doing this, as a result, there is not a one-to-one communication between users and public keys. Thus, so means is needed for identifying the particular keys. So to come to correspondings that both users and public keys, there is a connection is needed. There is a connection is needed for identifying that particular keys. So each PGP entity must maintain a file of its own public or private key pairs, as well as file of public keys of correspondence. So each and every PGP maintains one entity. So that entity is nothing but it shows the behavior of particular class or particular object. So Here the PGP entity must maintain a file which contains the pair of both public and private keys. The pair of both public and private key pairs, as well as public key correspondence also. For these three types of requirement, one is what means of generating unpredictable session key is needed actually. For what it is needed? Because of to generating the OTPs or generating captchas or generating password mechanisms. And second one is what making public key or private key pairs, which allows to user to decrypt or encrypt that public key with private key. So for that, and also maintaining each and every public key private key pairs in the file. Each PGP entity maintains what? A file with its own public or private key pairs, as well as the file of public keys of correspondence also. For these separate requirements, it identified with respect to the above keys. The first one is what? A session key generation. So each session key is associated with a single message. So each session key is associated with a single message and is used only for the purpose of encryption and decrypting the message. So the key of which key maintains what? The message which for either authentication or decryption purpose, either encryption purpose or decryption purpose. That is nothing but encryption plus decryption purpose is nothing but authentication. So recall that message encryption and decryption is done with the symmetric encryption algorithm. So we can call it as SEA, symmetric encryption algorithm. So this encryption and decryptions are developed or done with the help of these symmetric encryption algorithms. So here the input to the random number generator consists of 128-bit key and 264-bit blocks that are treated as a plain text to be encrypted. So the input to the random number generator. So random number generator generates random numbers randomly. The random number generator generates numbers randomly. So suppose if it takes the example like if it is generating, the first number is what? 1, the second number is what? 4, the third number is what? 3, and then fourth number is what? 7. Now this is making as a OTP code, or this number is making as a verification code, or this number is making as a some blocking codes, so reset code and everywhere. So for that all these codes, this random number generates some random numbers according to the generation of the keys. So which contains what? 128-bit key. This is a random number using the keystroke input from the user, and 264-bit blocks. So those two are treated as a plain text are to be encrypted. And using CFB mode, using cipher feedback mode, using CFB mode, 264-bit cipher text blocks are produced and concatenated to form the 128-bit session key. So 264-bit cipher blocks are produced. They produced some form of the key. To forming the key, they produced 264-bit cipher blocks and concatenated both them. 264-bit cipher blocks are combined or concatenated, then making it as a 128-bit session key. Then the algorithm is used based on the specified in ANSI X 12.17. ANSI X 12.17. We can name it as 12.17, not 12.17. Okay, so 12.17 we have to pronounce it. So this is the way of session key generation with the help of some random number generators. The next one, key identifiers. So it is possible to have more than one public key or private key pair per user. So more than one public or private key pair per user. So each and every user, suppose user 1 maintains one private key, comma, one public key. Similarly, user 2 maintains one private key or public key too. So here it is possible to have more than one public or private key pair per user, and each one therefore needs an ID for some kind, the key ID. So for generating this pair of public and private key, which is generated with IDs. So for this private and public keys, generating one key IDs. So for the second one, generating key IDs ID2. So that is what we mentioned here. Each of one therefore needed an ID of some kind. The key ID is associated with each public key consists of at least significant 64 bits. It's a least significant 64 bit. That is, the key ID of public key is treated as KUA mod 264. Actually, this is a sufficient length that the probability of duplicate key ID is very small. So for this, generating duplicate ID is very small based on the probability of this generating key. A key ID is also used for the PGP digital signature. As the sender may use one of the number as private, and it encrypts the message digest, and the recipient must know which one was used. With the key ID concept understand, a more detailed look at the format of transmitted message is shown in the figure. So the figure is shown in the figure is this one. So this is the PGP general format of PGP message. So general format of pretty good privacy message format. Message format. So PGP. So here we can see here the notations EKUB. So that is nothing but encryption with user B's public key. So there are two users having, one is user A and the second one is user B. So encryption with user B. Nothing but E. The key is what? Key user B. So encryption for the key with user B. Similarly, encryption for the key with private key. Encryption with user's private key. So that is nothing but EKRA. So indicating that what? Encryption with the user's private key. And encryption with the session key, EKS. So EKS is what? Encryption with the session key. And do the performance of zip compression function. And R64 is the radix 64 conversion function. So to make the message into small parts, making the message into blocks, or making the message into divided blocks, then we have to use this radix 64 conversion function. So these are all the notations that we have to use here. So the message format contains what? The first one, key ID of recipient's public key, that is nothing but KUB. So key ID, and the next session key. So session key is what? KS. The next timestamp key ID of sender's public key. So sender's public key ID of sender's public key. The next, leading 2 octets of message digest. And the message digest, that is nothing but message can be compressed, message can be reduced, and the file name which you want to compressing the file, and the timestamp, how much time you want to use for that file, and the data which contains in the file. So these are all the fields which understand that the session key components. These two are the session key components. What are those? Key ID of recipient's public key and session key. Those two are the session key component. Then next, for the purpose of doing digital signature, what are the requirements needed here? Timestamp is required. Key ID of sender's public key is required. leading 2 octets of message digest is required and message digest is required. So here we can say that this is a AKUB, that is nothing but encryption with user B's public key. User B's public key. So here user A's public, user's private key. So encryption with user's private key. This is encryption with user's private key, encryption with user public key, encryption with the user's private key, and encryption with user's public key. So here the file name and the timestamp contains data contents. So before performing the operations, the data has to be compressed. Then next applying the key concept, session key. Then next conversion function. So compress the file. Then next applying the session key generation. Then next conversion the function. Conversion of the function. So this is all about the general format, that is nothing but the message fields contains. The fields which are in the message format contains both key IDs and the generation of the key IDs along with the private or public keys. The next session key components, the signature, message, and the zip conversion. These are all the fields that are having in the compression of the PGP message. And the key rings. So key rings are nothing but it is one type of data structure which identifies that key IDs are maintaining. We'll see. So here key IDs are critical to the operation of PGP. Key IDs are critical to the operation of PGP. So from the previous figure, it can be seen that 2 key IDs are included in PGP message that provides both confidentiality and authentication. So 2 key IDs are generated and included. So they provide what? They provide confidentiality and authentication. So these keys need to be stored and organized in systematic way for efficient and effective use by all parties. So these keys need to be stored and organized in systematic way. So for what purpose? Efficient and effective used by all parties. The scheme used in PGP is to provide a pair of data structures at each node. One to store the public or private key pairs owned by that node, and another one to store the public keys of other users known at this node. So in the previous example, encryption with user B, encryption with the public key, and encryption with the private key. Encryption with the private key, encryption with the public key. So for other users, it is maintaining public or private key pairs, and other users are maintaining the public keys for that node. Other users are maintaining one public keys per node. So these are referred as, the key rings are referred as the data structures. Key rings are referred as data structures which maintains what? Which maintains key pairs. For one user, key pairs for one user, and public is for another user. So simply we can say that it is a data structure and it points towards the next node, and each and every node represents some types of key rings. Each node represents some types of key rings. So here these data structures are referred to respectively as the private key ring, and the public key ring. Private key ring and the public key ring. So we can view the ring as a table where each row represents one of the public or private key pairs owned by this user. So each row contains what? The following shows each row. So this is that we already said that key rings are maintaining as a data structures, maintaining as a data structures for what? For public and private key pairs and private key pairs. So here the key rings are having two types, like private key ring and public key ring. So general structure of private and public key rings we are showing here. The public key ring represents what, and public key ring represents what, and private key ring represents. So here the private key ring contains what? Timestamp, key ID, the next public key, and encrypted private key, and a user ID. So what are the fields in the private keyring actually? One is the timestamp, second one is the key ID, third one is the public key, fourth one is the encrypted public key, encrypted private key, then next user ID. User ID. So at the time T4, so when we are doing the sequence of operations, at the time T4, the key ID is what? The key ID is for public key, which mod 2 power 64, and here is the public key of the user A, and here applying the encryption procedure to the key, and then next the user ID, which contains user to transfer this encrypted data, and public key. So same, the public key contains what? Timestamp, key ID, public key, then next owner trust, that is nothing but digital signification or digital signature or verification, digital signature and verification, owner trust, then next user ID, the next key legitimacy, the next signature trust. So signature for the user and signature for the trust. So these are all the fields contains that indicates that containing key rings, public keyring and private keyrings, public keyring and private keyrings. So these two are the data structures types which maintaining key sessions keys or public keys or encryption private keys or encryption public keys for the two users, And from that figure, we understand that what timestamp represents the date or time when the key pair was generated. So date and time when this key pair is generated. And the key ID, the least significant 64 bits of the public key for this entry. The least significant 64 bits of the public key for this entry. And the public key is the portion of the pair. So public key represents the public key portion of the pair. The next private key portion of the pair, and the user ID. Typically, user's email address is the user ID. So here, the private keyring can be indexed by either user ID, key ID, or both. So the private keyring is indexed by what? The user ID. Indexed by what? User ID or key ID or both. So however, for security, the value of the key is not stored in the keyring. So however, for the security purpose, the value of the key is not stored in the keyring, but an encrypted version of it which requires passphrase to decrypt it. So as with all passphrase schemes, the security of this method depends on the strength of passphrase. And here, the next figure shows the PGP message generation without compression or radix 64 compression, using all the terms we have met in the reception. And the figure shows that this public key and private key ring figures showing that. So each and every timestamp, each and every public key, each and every owner trust, user ID, and all these fields are included in the key rings that are identified as security process. So these are all the PGP cryptography keys and rings that are included in the security services. So once again, we will revise the topics which we discussed in this session. So here we can see the cryptographic keys and rings. So what are the keys and rings? The first one is what? One-time session keys. Second one is public keys. Then next private keys, and passphrase symmetric keys. So there are 4 types of keys actually: one-time session keys, symmetric keys, public keys, private keys, and passphrase based symmetric keys. So for all generation of these keys, what for the requirement is what? Generating unpredictable session keys needed, and the second one is generating key pairs for the both public and private keys, and maintaining a file which generation of the public and private keys. So here session key is generated. So random numbers are used. Random number generators are used for generating random numbers, and a key identifier. So for each and every pair of the public and private keys, for each and every public and private key pairs, it is used key identifiers. It is used key identifiers. So there is a chance to use for the key IDs for each and every both pair of public and private keys. So here indicating that public key is user A and private key is user B. So indicating that what private and public key. So this indication is what for the public key. This indication is for public key and this indication is for what private key. Private key. And here we can see the PGP message format. So these are the session component. One is key ID, session key, and a signature. So what the signature field contains, and a message contains what data, timestamp, and file names. And when you are doing the process of encryption, the format fields are help to do the compression process, then next applying encryption process, and next conversion process. So these are all the fields are included in the PGP message format that are useful to provide the service of encryption and decryption process. And here key rings are used for the maintaining key pairs of both public key and private key of the users, public and private key of the users. So here some types of key rings are there. One is what private key ring and the second one is what public key ring. So these are the general structure of private and public key rings. And here the private key rings and indexed by user ID, key ID and both. And similarly passphrase symmetric keys are used to passphrase methods are used depending upon the conversion, depending upon the strength of the passphrase. So that's all about the cryptographic keys and rings. So without cryptographic keys, we are not able to do the encryption and decryption process for the data. So for that we have to know these cryptographic keys, right? So that is about PGP cryptographic keys and rings. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.